Okay. Okay, so you will find the files for this tutorial in the Moza server. In this directory. So this is the PDF file, and these are the two files that you have to download. This takes a little bit, about 10 minutes. So start doing that now while I do the presentation, and this is faster. So I have already downloaded this one, so we don't have to wait 10 minutes. So this presentation was done by Swen Julia, and I just adapted a little bit to this environment. Okay, then so first start doing make a directory called Benguela. I already did it. You move to that directory, and then you get the files that I just mentioned. So the work dir file I already downloaded because it's big. I'm going to get now the other one. It's called Benguela home. So this is the configuration directory, the home and the work dir where all the results will be done. This is like a bit of like the CROCO files directory that we had in the previous sessions. So now we uncompress this. And then we untar this file. Oh. So we have this, okay? So the next step is we move to the home directory, config Benguela, and we have all these files. So we have here a good explanation of what are the files and what are the different directories there. The key files are first run m that sets all the running environment. And then the run CPL is used to run a couple simulation. In this case, we're going to do CROCO with WARP, so it will be doing a couple ocean atmosphere simulation. So we have to modify this one. We will use this one to do the setup, and we will launch the simulation with this file that is similar to the run NLHPC that we had. And that is also related to this one. So all the CROCO files are related, are put in this directory. The OASIS files are in this directory. We have the WARF files here in this directory. The Waywatch that we will see tomorrow here. And there are toy models, simple models for ocean, atmosphere, and currents that we can use to couple each one with each other in different ways. So we will see, we will discuss this in detail. We can discuss this later. So take your time to explore this. So first, this one you have to modify because this is the one. There are two lines that are hardwired here. So you can recognize that we have the modules here. And we are here. So I'm now in structure 2. Okay, so this you have to change to your own directory. Remember, this one and this one. So for me, they work fine. And that's all you have to modify. Then in any new configuration, you have to compile CROCO with in the CPP devs, the ocean atmosphere coupling option. And also you have to check the param.h for parallelization. How many cores are you using to run your model? Remember to check the grid size. The grid is your matrix. Okay, and compile it. You will have to do the same for your WRF model. So in this case, we will run the default Benguela case, so everything is ready. But if not, you have to do it. Here I need to add the standard module loads for this process. And after that, after you compile, you have to move this to the croco.oa file name. So we will call this executable that is adapted to ocean atmosphere coupling, CROCO OA. Once you do that, take a look at this run couple OA file that has a lot of variables that you can read about them here. And at the end, once everything is copied to the work directory, you can launch the simulation with this script. So let's look at this first. Launch couple. You can see that it's very similar to this to the run NLHPC that we had before. And when it calls the code to run, it uses this file, myrun.conf. Let's look at it because it's very interesting. What it says here is you will use the WRF executable with 16 cores, and you will use the ocean model with 4 cores, 16, 17, 18, and 19. So of the 20 cores, we have assigned for this task, we will use 16 in Wharf and just 4 in CROCO. And these are the names of the executables. Here it should say OA instead of OX, or vice versa. Okay, so now I do this batch. Run couple OA. And what this will do, we'll do is copy the files to the other directory. Okay, it finished already. So I will go to that directory, like I mentioned here. Output, couple, ocean atmosphere. So let's go take a look at this. So here are several directories for all the configurations, or many of the configurations we can do. Our configuration now is ocean atmosphere, so we will work in this directory. Ocean atmosphere. So we have everything here. You can recognize from Wharf. Here's the executable. Here's the input file. Here's the boundary file. You can see where is CROCO. Here you can see the files for CROCO X. Here are the grid, forcing brief files for CROCO. So, and like I was mentioning, the launch couple command is this. Okay, so we have to add, okay, so there's something that it wasn't changed. So we will add one step here. Launch couple command. Here I will call this instructor 02 ocean atmosphere. And here you have to add curso UDEC, because the file didn't copy that. Reservation curso UDEC. So we will use the nodes that were reserved for this online course. And okay, and this will call my run.conf. Okay, Control O, Control X, my run.conf. Oh, here is also, you need to modify this. Is Wharf X, no dot. Here's this is. I need to change that script, but just minor details that are not in the tutorial. So please take a look at, take care of them. So now I do sbatch launch couple, and I can see that this is running in one of the nodes that were reserved for us, 119 to 122. and it's running. So now I can do ls minus lh, and I can see if you have used WRF, you can recognize these output files. Here's our WRF output, and you can see other files from CROCO. So we can see the CROCO heath that is being created, etc. This is a short configuration. It's a simple configuration. We can see the num couple file that is used by Oasis here. It has all the details for this coupled run. Okay. The fields being exchanged, the dimensions of each domain, 4142 for the ocean model, 5650 for the atmosphere model, etc. So, and it's quite fast because it's only 3 days. But we're many, so even then you will be on the queue for this no. With this command, you can see if there are other nodes available. In this case, all the standard slim nodes are busy, so we're lucky to have 4 for only for now for us. Yeah. Okay. So that's it. That's what you have to do. With that, you will be doing a couple ocean atmosphere simulation. You could also do a normal CROCO run if you recompile the model without the ocean atmosphere coupling. And you can use this simulation to compare with the one we will obtain here. So questions?
A lot of questions.
Okay. Please first do the run, and then we start with the questions. Start downloading the data. So it's better. I prefer if you tell me I tried this and it doesn't work, than you tell me how do I do it, because my answer is do it and let me know what doesn't work. So first do it. If something doesn't work, then you can ask about why it's not working, and then if it works, you can ask more details about how I do it, how do I do this, how do I do that. Okay, we have a good question here from Rodney about the WRF version. This is 3.7, but it has some modification for what I understand. So I know, Swain, you can explain a little bit about these modifications from the WRF code.
Yes, I think actually it's a 4.2 version that we have run in your machine.
Okay.
But yes, we have some modification because we actually the distributed version of WRF at the moment include coupling with Oasis and so potential coupling with CROCO. But we have now added additional coupling for coupling with the waves. And this is not actually in the distributed version of WRF. That's why we have a special version for that. And we have also introduced the use of the XIOS IO server. And this is not at the moment distributed by WRF, but it will be soon, hopefully.
So for someone who wants to only couple CROCO and WRF, they can use the default WRF code?
Yes, sure.
That works. And
Yeah.
that works. Sorry, there was another question that the OASIS coupler is one has to use this 3.1 or 4.0?
I think that we have run the code with both. Actually, it won't be an issue.
Okay.
So usually we try to keep the codes up to date, so that we can run with all the up to date version of the libraries and of the different codes. So yeah, it should work. I don't know actually what modules you have for Oasis. I haven't tried it, but it works with the 4. I guess it works with the 4 version too.
Okay. For some reason we installed 3.1 here, but maybe 4.0 was okay.
Yes, usually they when they update the library version, they keep backward compatibility, even if we have old stuff in the code.
Okay.
And just maybe regarding the WAF distributed version, one thing that maybe is not included is stuff about rotated grids, because I know that we have made some developments about that. So if you want to couple a grid that isn't oriented toward the north and the east, but a bit rotated, for example, for kind of a coastal or littoral application where the rotated grid is better. Maybe it's not yet in the WAF distributed version. I have to check. I don't know.
Okay, great. Thanks. It's more clear now.
Yeah.
Questions? Questions on the tutorial? Yes, I think I don't know how I can share the file. Joaquim is asking about sharing the big file. Maybe. Yeah.
Maybe you can just give the access to copy your directory from the machine. I don't know if people are working on your cluster.
Yeah, I will try that. So let's stop broadcasting.